traveling to determine the x value of its vertex because it's symmetrical, right? So if I want to find the vertex, I need the x value and the y value. So the first thing you're going to measure is just how far does your ball go? So if it goes 20 feet, guess what? The vertex was at 10 feet, halfway in between. So to me, the x value is the easy part of the calculation. Whatever your distance is, just cut it in half. So in this above diagram, if the projectile lands 50 centimeters away, because we're launching it off the ground, what does the x value of the vertex have to be? It has to be at 25, right? If this is 50, then halfway must be 25. There, you already know half of your vertex. So then it says we need to find the maximum height that our projectile flew, which is the y value of the vertex. So here's where gravity comes in. You must find the average fall time. This is fall time, right? So it's in free fall towards the ground for half the time it's in the air. So if your partner says ready, set, launch, and you launch your ball and it takes 2.4 seconds to launch, then if this whole thing is 2.4 seconds, it was in free fall for 1.2 seconds. So you need to know how long the time of your free fall. So in the diagram above, if the object was in the air for a total of 2 seconds, how long was the free fall? 1 second, right? Half of the time. So you're going to measure your distance. You're going to cut that in half. You're going to measure your time. You're going to cut that in half. And here's where the physics equation comes in. So any object that's in free fall with gravity, the d, the vertical distance of the free fall, which for us is the height of the parabola, can be measured by this equation. 1/2 the constant of gravity times t squared. T is our time. So d is the vertical distance we're looking for. G is the effect of gravity. So you could either use 9.8 if you're in meters per second squared, or 980 if you're using centimeters per second squared. So you just have to choose the correct constant. Sometimes we'll measure in meters, sometimes we'll measure in centimeters. So it depends on how you're measuring your distance. And you plug in gravity and the average free fall time, and that finds the maximum distance. So we're going to do 1/2. We're going to use 980, right? Because we were dealing in centimeters in the diagram. And t squared for us is just 1 squared. So 1/2, this is the constant with gravity, and our time was 1 squared. So how high did this projectile launch? We're just going to do 1/2 times 980, which is what? Is that 490? All right. So 490 centimeters is the y value of our vertex. So our vertex is at 25, 490. So all you need are those two measurements: the time it's in the air, the horizontal distance that it traveled. Basically, each of those values are going to get cut in half to use them to find our vertex. So step 1, you find your vertex, and you can follow these steps, pretty exactly. And we're going to do one more practice on this in a minute. So then, guess what? We can write vertex form. We have 25, we have 490. We can write vertex form of the parabola on the next page. So let's recopy what was our vertex, 25, 490. And it says, let's fill in those values for h to go right 25 and k to go up 490. The only value we don't know is a. So we don't know the steepness, we just know that it's upside down. So we're going to write y equals a, x minus, 25 squared plus 490, right? We just spent a whole unit learning about vertex form and transformation rules. Do you see how this goes like hand in hand? Now we're writing the equation of a real world object using that format. And it says we still need to solve for the A value. So here's your last step. What other point do we know lies on this parabola? Well, we know the vertex, but we also know this point right here, right? That x-intercept needs to be at 50, 0. So it says we can use the point 50, 0, plug it into the equation for x and y, and that will allow us to solve for A. All right, so I'm going to plug in 0 equals A times 50 minus 25 squared plus 490. So once you have vertex form set up, then I'll help you with these steps if you need help. You plug in your x-intercept, which was 50 for x and 0 for y. Can someone help me solve for A? What order of operations should I do to solve for A? So this is just using algebra. What should I do first, do you think, Anya? Parentheses. And 50 minus 25 is 25. So I have A times 25 squared plus 490. What do you think I should do next? The exponents. 25 times 25. Is that 625? Can someone check for me? 0 equals A times, is that right? It is 625 plus 490. Now you're solving a linear equation. How do I get A by itself? How do I move things to the other side of an equation? What would I do first? Yep, let's move the 490 to the other side. So negative 490 equals A times 625. And what's my last step to solve for A? Divide, right? Divide by 625. If you want to leave it just like that, and you don't want to write it out as a decimal or reduce it, you could just leave that as your A value. I don't know what it reduces to. Did someone figure out what it reduces to? Did you have a question? Yeah.
No.
Yeah. It reduces to the value negative 0.784. If you'd rather write it like that, is that more steep or less steep than the parent function? Less steep. If it had come out to 1, it would have been the parent function, right? More than 1, it would have been steeper than the parent function. So our final equation is y equals negative 0.784, x minus 25 squared plus 490. So see how it has my vertex included and the steepness factor? And that's a really challenging physics-related math problem that you just did. But I think because you've studied vertex form, you have a general understanding of why this is our vertex. And using some algebra skills from earlier in the year, you're able to solve for this unknown A value, and it makes sense that it would be concave down. So I don't think it's past your math ability, but you kind of need the step-by-step in front of you to do it. So let's just do one more example together today, and then I can come around. If you're on this step today, maybe you'll be on this step tomorrow and need help, but we'll warm up with example 2 tomorrow. Let's just do example 1. Here's a different projectile. You're going to see that the steps are identical. So the projectile started on the ground and it landed 12 meters away, right? So this point is 12. Here's my projectile. This is your next page, right? But it's in meters this time. The units are important because of the constant of gravity, right? And it was in the air for a total of 5 seconds of launch time. Those are the two measurements that you need from your catapult. So even if you don't do the calculation today, by the end of class, I hope that we could at least do our launches to get our data so that we can start with our calculations tomorrow. All right, what's the x value of the vertex? It's exactly half the distance, right? So the x value of my vertex is 6, right? Because 12 meters was all the way, 6 meters is halfway. All right, the y value of the vertex. What's the time of free fall? 2.5 seconds. So I do 1/2 times the constant of gravity. I'm using 9.8 this time because I'm in meters, not centimeters. And then I'm going to do 2.5 as my time squared. That will give me the y value of my vertex. So this is 2.5. So if you do I just type it in one fell swoop, 0.5 times 9.8 times 2.5 squared. That way my order of operations, they're all contained. 30.625. This is a pretty high projectile. 30 meters in the air, pretty high. If you think about launching something for 5 seconds, that's actually quite a long time for something to go up and come down. When you think about throwing a baseball to someone, it gets to them in a couple seconds, right? Throwing a baseball. So 5 seconds is quite a high launch. All right, so then it says write the equation of the projectile in vertex form. So that's y equals a x minus 6 squared plus 30.625. There's my right 6 up 30.625. Don't forget that squared symbol. It's not a quadratic without the squared symbol. On your test, I really wanted you to say that. I wish you had said that about what's the difference between linear and quadratic? Quadratic has an x squared in the equation. All right, now what am I going to plug in for x and y? What should I plug in? I need to plug in a coordinate from the graph. Yep, I'm going to plug in 12 for x and 0 for y because that is the x-intercept. And you can kind of follow the pattern that we did last time. We're going to subtract the k value, right, to the other side, and then basically divide by this value that's next to the a. But if you want to do it in each step for yourself, that's good too. So I'd have 0 equals a times 6 squared plus 30.625. This is the number 36. I didn't leave enough room apparently. Negative 30 point. If you don't get a negative, you did something wrong because these all have to be concave down. Did you get about negative 0.85? Or you will, probably. Half of this number squared, and then you're going to subtract this number. What else did you notice about it? Half of what were you going to say? Yep. Yeah, it always will be because the point that we're using is this doubled point, right? So it is, yeah, you can figure that that's the pattern. I mean, it's basically you're going to subtract your k value to the other side and divide by this number squared, right? That is your a value. Yep, it's gonna be that way every single time. So what the goal is for Friday is we'll use our equation to figure out if we launch from a desktop, where can we predict that it will land based on using the calculator. Question, Haley? No? Okay. So we'll do example 2 as a warm-up tomorrow. If you need help today and you're on the calculation part,